Hello, my name is Andy Connolly and I'm an educator at the Kansas Geological Survey. If you've ever driven across Kansas, you've experienced our rolling hills and landscape that stretches for miles on end. Yet underneath this land are stories locked in stone and tell us a world much different than it is today. In this episode, we'll explore the geologic history of Kansas and learn about its many ancient habitats and animals that once lived here. Let's dig in. Geologists are scientists who study the Earth and its natural resources, such as rocks, minerals, and water. Stratigraphers are geologists who specialize in studying rock strata, or layers, and piece together the Earth's 4.6 billion year history. Using clues within the strata, like rock features or fossils, they can infer how environments have changed over time. Our first stop in the geologic history of Kansas begins here, in Schermerhorn Park in the extreme southeastern corner of Kansas. This is the oldest exposed layers of rock in Kansas. They date to the Mississippian era, about 345 million years old. Within these layers of rocks, we can find fossils like crinoids and trilobites, ancient denizens of an ocean long since past. Over millions of years, rivers carried sediment into the oceans. This sediment gradually sank to the seafloor and solidified into shale, limestone, and sandstone. As you travel across eastern Kansas, we can observe the repeated layering of shale and limestone into the landscape. This is preserved evidence of ocean levels changing back and forth between deep and shallow over time. We jump forward now to 300 million years ago. Fossils of fish and insects, alongside plants such as these, tell us that Kansas was once home to a warm and wet coastline. We can also find some of Earth's earliest reptiles as well. Now, as these forests grew, the trees eventually fell over, were buried, and pressurized, forming coal. These rich coal deposits are now spread out across southeastern Kansas and are all that remains of this once ancient ecosystem. Then, around 280 million years ago, during the Permian period, the sea indirectly formed one of Kansas's most famous features, the Flint Hills. As the seas deposited layers of shale and limestone, massive amounts of microorganisms died and were buried within the rocks. These silica-rich microorganisms recrystallized into chert, forming within the limestone. After the oceans retreated, the chert was slowly exposed through erosion. The chert was hard though and resisted the pounding rain and wind, and as such, the chert acted as a barrier and protected the underlying soft shale. This protection created the Flint Hills. Some 20 million years after the formation of the Flint Hills, the seas fostered the creation of the Red Hills. However, unlike the cherty Flint Hills, the Red Hills of south-central Kansas are capped by gypsum. When the ancient Permian Sea was drying up, it deposited massive loads of salt and gypsum. Like the chert, the gypsum created a protected shield around the softer minerals, creating the Red Hills. The hills get their name from iron within the rocks, which turn bright red when exposed to oxygen. The gypsum and salt are now regularly mined in the region and serve as economically important minerals for communities. We skip forward now to 80 million years ago, during the Cretaceous period. The sea cuts across Kansas and brings with it famous animals like the Tylosaurs. These marine reptiles swam alongside other animals like giant clams, ammonites, bulldog-like fish, and plesiosaurs. Overhead, flying reptiles like pteranodon hunted the sea like ancient shorebirds. We can find these fossils across western Kansas, like the Smoky Hills and the fantastic Little Jerusalem Badlands State Park. The Tylosaurs and the pteranodon are so iconic that they're now our state fossils of Kansas. Approximately 66 million years ago, a new dramatic force finally spelled the end of Kansas oceans. Shifting plate tectonics created the Rocky Mountains, which rose upward across western North America. As they rose, the oceans drained away, never to return. Rivers eroded the mountains and deposited huge amounts of sediment across western Kansas. The Ogallala Rock Formation was the result of these deposits. Fossils of rhinos, horses, ant nests, and plants indicate that this was a rich grasslands environment. However, the Ogallala Formation's most defining modern characteristic is the Ogallala Aquifer, a large underground source of water that spans most of western Kansas. As this region receives little annual rainfall, the Ogallala Aquifer has served as an important source of water for people for many years. One of the last major geologic influences in Kansas happened during the Ice Age, some 700,000 years ago. Glaciers crept down from the north and brought with them huge boulders of rock called Sioux quartzite. These boulders range from the size of your fist to the size of cars and are spread out across northeastern Kansas. Among these rocks, we can also find Ice Age mammal fossils, including mammoths, mastodons, and giant ground sloths. Although Kansas may seem stagnant today, it's still influenced by the forces of geology. Sediment comes in from the Rocky Mountains, rivers meander and change courses, and rocks tumble down through the forces of wind, rain, and snow. Through these gradual changes, the landscape will once again transform and be very different from what it is today. I hope you enjoyed today's video. If you would like to learn more, check out our website and other videos, and we'll see you next time.